Hi everyone. Good evening, good morning, good afternoon, depending on the different time zones you are in. My name is Ajit Singh Vadhavan. I am the speaker for today's session. Today I will be speaking on cloud computing, key models, core traits, and future career scope. If I'm audible, please confirm me on chat window. If someone is there, then please confirm me on the chat window. Okay, so let's start the session. So today I will be today I will be covering some few topics related to cloud computing. The main purpose of this session is to kill two birds with one stone. That is, with the help of this session, I will take you through in a world of cloud computing, what is cloud computing, and careers about cloud computing. At the same time, this will prepare you for course content on CISSP, CompTIA Security Plus, CISA, and CISA. So let's start now. So this is about exploring cloud computing. My name is, as I've already mentioned, I am a speaker for today's session. The agenda for today's session is introduction, what is cloud, why cloud computing, essential characteristics of a cloud, deployment and service categories of cloud, then what is cloud security, and careers in cloud. So first five parts, first from two to four, it will help you in preparation of CISSP, CISA, CISM, whichever information security certifications, your InfoSec management certifications you are preparing about. Then pointer 6 and 7 will take you about cloud security. At the same time, pointer 7 will I will deep dive into career in cloud security. Although in cloud, it's not in cloud, there are many careers available. It's not only people with technical background can make their career. There are many options available. I will take you through that. So a brief introduction about me. My name is Ajit Singh Vadhavan. I have 20 plus years of experience. Now 21, I can say that in auditing, SOC. I worked as a head of security operations, delivered many security testing projects, worked extensively on security technologies. Prior to moving into my training career, I have worked into audit and compliance for 5 years. I have 20 years of experience in training also. I have conducted 500 plus training sessions on CISA, CISM, CSSP, CCSP, C-Risk, SSCP, and Security Plus. I'm ISC2 authorized trainer for CSSP and CCSP, and ISACA authorized trainer for CISA, CISM, and CRIS. I have 23 plus certifications, and it is still counting. So that is a brief introduction about me. Now, what is cloud? Cloud computing, in simple words, if I talk about, it is using someone else's computer to do a job, and that is over internet. Earlier days, like I would say 2014-15, when I used to go for training in out of when I used to go out of town trainings, I used to carry my hard drives so that in case of any issue, I have my data available on my hard drive. But these days, that's not required. I have my data available on Google Drive, OneDrive. Wherever I go, if there is an internet connection, I can use it. Earlier days, if you want to set up a lab, like I used to teach I used to teach CCSP, not cloud CCSP, Cisco Certified Security Professional. For that, I have to set up labs on my computer. But these days, labs are easily available on a cloud. Remember I still remember CH labs we used to set up on our systems. But these days, iLabs are available. Try Hack Me, Hack the Box. Everything is available in a cloud. We don't need to do a lot of hassle in accessing it. We don't need to purchase machines for it. So cloud is someone else, as I already mentioned. It is a use of remote servers on the internet to store, manage, and process your data rather than your local server or local computer. Another example, earlier days, companies are using backup tapes, magnetic drives magnetic tapes or backup drives to store your day-to-day data, backup data. And magnetic tapes and drives, they are uh, not very durable and they are subject to decay over the period of time. So companies are moving towards the cheaper alternative on cloud storage like AWS S3, Azure blob. So there are many, many cases available where cloud has become a very formidable option and alternative. So why cloud? Cloud can be used for hosting the small websites. Small businesses can launch a website without investing in expensive servers and IT infrastructure by using cloud services like AWS or Google Cloud. It can help you in remote work collaboration. I just give you a simple example. My daughter, she's 15 years old. She's the one who prepared Canvas slides for me. Although I can also prepare, but I have outsourced it to her. So we have a Canva available on my system, on her system. So she prepared the slides on her system. From my system, I can download. If I need to modify, I can easily modify also. So this is a very simple example of remote work collaboration, but you can see the Google Workspaces, Microsoft 365, then programmers available in a different programmers available in a different parts of the world, they can collaborate and work on software projects. Netflix, you will be amazed to know that, surprised to know that Amazon Cloud started in 2008 and Netflix was the first one to start using their services. Netflix has been using cloud services since 2008. So it can be used for streaming video services like YouTube, Netflix. They use cloud infrastructure and content delivery network to deliver videos globally, ensuring fast. There are many, many use cases available. Like I've already given examples earlier, like you have a storage space. You don't need storage space now in your organization. You can use cloud storage space, which can be very cheaper for you. Earlier days, you have to have the BCP and DR sites maintained, but these days, it's not required. You can have a BCP and DR sites available in a cloud. In 2007 only, I first laid out my hands on College Guard. College Guard was what? College Guard is a vulnerability scanner hosted in a cloud. So there are many endless services available, which I can talk continuously for hours and hours, but that will not end. So these are some of the examples I have given it to you. So as per NIST 800-145, National Institute of Standards and Technology, there are 5 essential characteristics, 3 delivery models, and 4 deployment models. So I will take you through one by one. So what are the cloud computing characteristics? There are, these are mentioned here. So you will notice in the previous one, I have mentioned 5, but here there are 6. So there is another standard of cloud, which we call as ISO 17788. So that has 5, NIST 800-145 and ISO 17788 has 5 characteristics in common with ISO 1778 has one extra characteristic. So I'm covering all 6 characteristics here. The first one is resource pooling. Let's take one example. So there are 4 family members in house, father, mother, son, and daughter. They are earning $4,000 each. And father and mother, their expenditure are $5,000 each, and son and daughter expenditure are $1,500 each. From the very first month, father and mother will be in debt. But if they have combined all the money together, so total money is 16,000. Father and mother can take out $5,000 each. and son and daughter required $1,500 each. So still, after spending all the money, they are left with surplus money of 3,000. The same concept is applicable to resource pooling. You It is the practice of combining and managing various physical and virtual resources like servers, storage, network into a shared pool. So these pool is available to the cloud customer. They can pick up the resources as per their own requirement. Cloud is virtualization. In a cloud, the complexity is abstracted. What is abstracted? Abstraction. You cook food in your home. You can easily see how food is cooked. But if you go to hotel, same food, you will not be able to see that how it is cooked. So it is abstracted from you. So same hardware, same software, virtualization is there, but it is abstracted from you. So it is a pool of resources that has been combined together and you can use it as per your own requirement. Then you have a rapid elasticity. Another example. Suppose you have an application abc.com which require 5 servers to run properly. In the night for 1 hour, you require 5 extra servers, means 10 servers. So for that 1 hour, when you require extra 5 servers will be provisioned, and you only have to pay for 10 server during that 1 hour time. Rest for 24 hours, you will only have to pay for 23 hours. You only have to pay for 5 servers. So resources can be rapidly provisioned, deprovisioned as per the requirement. And if we don't have a cloud, then you have to purchase 10 servers in the beginning only. And you can see for only for 30 hours in a month, you will be requiring 10 servers. Rest that all other 5 servers will be a kind of a waste. Broad network access, which means that you can access the cloud services from various devices such as laptops, smartphones, tablets using standard network protocol. This ensures that user can access services from anywhere, promoting flexibility and mobility. Again, you have to remember this point. This can only be possible if you have to consider this fact that it should not be restricted, because in a cloud you can restrict that, okay, I don't want people from this locality to be accessing my data. That can also be a possibility. You can do that restriction. I'm not doing any business with people of China, just an example right now. Okay, so in that case, I can set up a restriction that these IPs, which belongs to China or Pakistan IP, no, they are not allowed. Just an example. Then measured services. You only have to pay for what you are using it. Like in our house, we have electricity. Electricity bills, we are charged for electricity on the basis of our usage. The cloud system track resource usage and provide detailed metrics on the consumption, and you will only be charged on the basis of what you are using it. Then you have multi-tenancy. I live in Delhi. Delhi is a metro city. I'm from a city called Jabalpur, where still independent houses are possible, available. But in a city like Delhi, where there is a scarcity of a space, I can't purchase an independent house, so I'm living in a floor. So same concept here. These days, having independent hardwares, it will unnecessary add cost, greenhouse effect, and many other things. So that's the reason we are moving towards virtualization, where we can host multiple virtual boxes on one physical box. So this is called multi-tenancy. But remember, multi-tenancy, you have to take care of your security. Like when you are living in your home, you are the only one who's living. But when you live in a hotel or staying in a hotel, there are other guests also, so you have to take care of the security. On demand access. So remember earlier days, if you want to deploy a server, so you need minimum 1 to 2 month to deploy the server and application on top of it. Let's take an example. You want to configure the DNS server. In that, first you need to make a request to procure the DNS server hardware and then purchase the license for it. And then you will configure the application and all. This will take minimum 1 month. But with cloud, go to the cloud, there is a console available. You can request for hardware and choose an operating system. It is a matter of 15 minutes to half an hour, depending on your resources. So these are six essential characteristics, 5 plus 1 essential characteristics of a cloud. Cloud is also, as per NIST 800-145, cloud is categorized on the basis of four deployment model, that how it is being deployed. First one is public cloud. The public cloud, the cloud infrastructure is provided by a third-party cloud service providers and is made available to the general public or a large group. Like for example, Google Drive. Anyone can use it. It always exists on a premises of a cloud provider. The infrastructure is owned and managed by the provider. They offers you services like storage, compute, and many other services which you normally excel, which you normally prevail on a pay as you go basis. So whatever is your money means whatever is your requirement, you can give it. So examples of that: Google Drive, Dropbox, AWS, GCP, that all comes under public cloud. Anyone can go subscribe to the services, pay money, and use it. Then we have a private cloud. So here the infrastructure is dedicated exclusively to the single organization. It may be it may be managed either by the organization itself or by a third party provider and can be located either on premises or off premises. So here you can get it set up in your environment. It can be managed by your organizational people. It can be managed by other people also. Okay, so up to you that this model offers greater control, security, and customization, often comes with higher cost. Examples of that is VMware Cloud, Microsoft Azure Stack, that all comes under. But again, this is very, very costly. So this is being used in those cases where you need to process the sensitive data or there is a strict regulatory requirement. So be very careful about the cost factor associated with it. Then we have community cloud. Community cloud is, let's take an example. Suppose there are three companies, A, B, C, they're training companies, which are offering CH services to their customers, their students. One solution, they can set up their own, they say they can set up individual private cloud for their students exclusively. But that would be a very costly option. So other options they can choose is they can come together, set up one combined cloud which can be used by students of all the three companies. So this is community. So it is not, it sits between public and private cloud. It is costlier than public, cheaper than private. It can be located on premise or off premises. This model provides a balance between exclusive nature of a private cloud and the broader access of public cloud catering to the specific community needs. Another example, there are four companies, Indian companies, pharma companies, which are doing business with US. US, it is subjected to HIPAA. So they are processing PHI data, which means that all these four Indian companies, they should also have systems which are HIPAA compliant. So one solution, they can set up their own cloud. Other solution, they can come together, set up one community cloud, which can be used by people of these four companies together. Now, pricing and all, they have to take care of it. That is definitely a concern. I will not go into details of it because that's altogether a plethora box. Then comes hybrid. Hybrid is a combination of any cloud, public plus private, private plus community, IaaS plus PaaS, PaaS plus SaaS, depends. But if I go for an ideal combination, it's a combination of private plus public cloud. Let's consider two use cases of hybrid cloud. You are using a private cloud for processing sensitive data, but you have not so sensitive bulk data, which you can't afford to run and process in your private cloud. So you can use public cloud, private cloud to process sensitive data, and public cloud to process not so sensitive data. One example. Suppose there is another, suppose you are you have a private cloud which can handle 100 GB of a data every day. But every 1 month you go for a sale, you organize a sale, and in that the daily traffic crosses around 150 TB, 150 GB, means 50 GB of burst. We call it burst. So what you can do, till 100 GB, it will use your private clouds, and another 50 GB, which is the burst, you will transfer or migrate it to you will transfer it to public cloud for working for processing. So this is the one which is a combination of two or more types of cloud that remain distinct, means they retain their identity but are bound together by standardized or proprietary technology, allowing data and applications to be shared between them. So these are four deployment categories: public, private, hybrid, and community. So as per NIST 800-145, they have three service categories. That is infrastructure as a service. First one is infrastructure services. It's a cloud computing model that provides virtualized computing resources over the internet. Let's take two examples. I want to set up a Kali Linux machine for my hacking practice. One solution that I have already done in 2020, I purchased a laptop and I set up VM labs and I install VM and then I install Kali Linux operating system on top of it. So this is one option, but this is your own computer. But recently, I because my laptop is old, so what I did, I took a services of, I went to cloud, AWS, I provisioned machine and install a Kali Linux operating system on top of it. So this is what infrastructure services. I need, I am using, my organization is using backup tapes. I don't like it. I don't like it. So what I want that what so I'm looking for an alternative. So what I have done is I have chosen AWS S3 storage space. So instead of backup tapes, all my data is stored on a cloud. So this is another example of infrastructure storage. So it offers you servers, virtual machines with varying configurations. It offers you storage such as block storage, which users can manage without worrying. It offers you networks, like you can set up your own data centers. Like in AWS, you have VPC, that is virtual private cloud. So these are also called as SPI tiers, storage, platform, and infrastructure. Examples of that is Amazon EC2, it's a VM machine, Google Compute Engine, HP Cloud. Then we have platform as a service. Let's take one example. Suppose I'm a programmer and I want to develop an application on Java platform. And in my organization, we we don't have Java platform. We have Microsoft platform. I requested my boss. He said, for you, one individual, I can't purchase a license, but I give you permission to go and use the cloud services like Azure or AWS, because they have a platform as a services where multiple platforms are available at your disposal. Microsoft, Java, multi Python, many platforms. So you can go. deploy your application, provide me a proof of concept. If it works well, I can help you with that. Then I can think about it. So you don't need to bother about the infrastructure below it, because when you need to deploy some application, you not only have to think about application, but about the servers on which you host your application, licensing, routing, load balancers, everything. Here you give a damn about those things. What you are interested in, what you need to care about is application. Rest everything is a cloud provider responsible. So they provide you a platform, go there, deploy your application, job done. You don't have to think about complexity of building and maintaining the infrastructure associated with developing and launching an application. Example of that is Google App Engine, Microsoft Azure Cloud Services, EJV in Google, you in Azure AWS, you have Enterprise Java being something like EJB. So then we have a software as a services. Here you don't need to worry much about anything. Like I'm using Canva. I just have to open the I have to just I've installed an application on top because you have thin client, thick client. I am using a thick client. I've installed an application. I use that. I have not to worry. I don't have to worry about anything. It's a full application that's managed and hosted by provider. The consumer access with the web browser, mobile application, or the lightweight client application. So in a cloud, we follow the shared responsibility model. Like when you live in at your home, you are the one who is responsible for everything, correct? And you don't need to bother much about it. But when you go to hotel, then you and hotel owner share the responsibilities. So same concept here. When you have a data hosted in your data center, you don't need to worry much about security. But when you have a data hosted in cloud, then cloud provider administrator also comes into the role, comes into the picture, and then you have to access that thing over the internet. That's the reason in cloud we follow the shared responsibility model. This framework outlines the division of security responsibility between the cloud provider and cloud customer, ensure that both parties understand their rules. Like in IaaS, cloud provider is only responsible for providing you VM machines. The operating system that you're installing is all the responsibility of a cloud customer and application you're installing and data. Similarly, in platform as a services, cloud provider is responsible for VM, even the platform. The application and data you are installing is the responsibility of a cloud customer. And then in a cloud SAS, you are only responsible for data. Rest is everything is responsibility of a cloud provider. So this is about NIST 800-145. This can help you if you are preparing for CISSP, CCSP. CCSP is more in depth, but CISSP, CompTIA Security Plus, CISA. So this will help you about it. Now, next topic is about cloud security. This is so what is cloud security? Look, when we talk about security, security consists, we people think about security is only about technologies. No, security is not only about technologies. Security is all about people, process, and technology. Suppose you have a firewall. Tell me, can firewall work properly without people? No. Can people work properly without having processes? No. Because people, firewall need people to run and firewall need people to work proper. Firewall need people to run that, and people need processes. So cloud security refers to the set of policies, technologies, controls, and procedure to safeguard data and application. And whenever we talk about security, security is measured on three fronts: confidentiality, integrity, and availability. And cloud security is no different from that. But here you have to be extra careful about security, because here you have data stored in someone else's data center. So why cloud security? Cloud security is crucial due to the widespread adoption of a cloud computing and sensitive nature of a services managed in the cloud. We need cloud security to protect our sensitive data. Cloud security safeguards sensitive data from unauthorized access, breaches, and malicious attacks. These days, governments and industries around the world, they are tightening the grip around these companies with the help of regulations. Without compliance with regulations, you can't do the businesses. So that's the reason cloud security is important to help you in compliance with regulations. With the advancement of technology, the cyber threats are also increasing a lot. So it helps you in mitigation of cybersecurity threats by implementing firewalls, encryptions, IDS. BCP, ensure business continuity. Cloud security helps in maintaining what is BCP? Having measures in place to ensure the continuity of a business is maintained. So cloud in itself is redundant in nature. So to ensure business continuity, the cloud security is important. And then manage the shared responsibility. This is kind of a big pain for people, because most of the time people we are accustomed and habituated to manage service provider model, where they are in a habit of blaming everything to the provider. But in cloud security, that thing won't work, and then they get a surprise of their lifetime when provider go back when provider reverts and saying that no, this is your responsibility, not my responsibility. Then they get a surprise of their lifetime. Then they understand that cloud is not only about uh, blaming everything to the provider. You also have to be aware of your responsibilities. Like if it's your data, it's your data, you have to take care of it. So, cloud security objectives, data confidentiality. Ensure that sensitive data is accessible only to the user and protected from unauthorized access. Make sure that data available in a cloud is accurate. It should be available. That's the reason cloud has a concept of availability zones and regions. It helps in compliance with regulations like GDPR, HIPAA. It helps in mitigations against the risk, identifying potential risk and vulnerabilities in a cloud environment, and how to measure how to protect and mitigate them. And then protection of data loss, implementing measures like automated backups, disaster recovery plans to prevent data loss in case of hardware failures. Because although cloud has redundancy in itself, but we have seen instances where cloud was also down for long time. I remember in 2018 or 19, Amazon EC2 instance outages happened. There was an outage in EC2 instance, and due to which EC2 instances were unavailable for 1 to 2 hours. In 2020, uh, during the COVID time, we face a resource crunch. Azure cloud face a resource crunch in a European region. So yes, these are some of the objectives. And the next slide will tell you about why this is important. In 2019, a hacker breached a Capital One's AWS environment, stealing millions of data because of a misconfigured firewall. Researchers discovered a vulnerability which allowed the attackers to access the databases. T-Mobile's 21 data breach that caused the loss of 40 million customer data, including social numbers. Then I remember one case where Nice System, Nice System, the subsidiary, the contractor of Verizon, they uploaded the data on an open S3 bucket, and that caused a breach of millions of data, 17 million customers' data. So it itself tells, these statistics itself tell that why cloud security is important. This is about your cloud. So next one I will talk about the how to go for, means what are the different career options available in cloud. So I will be focusing more on cloud security, But again, as I already mentioned, cloud has roles available for everyone. So you will see in my slides that it is not only about technical roles, non-technical people can also have their career made into the cloud. So organizations these days are considering cloud for their business. Study shows that 86% of the business uses cloud-based services in different forms in the world. There are people who are saying that there's a reverse migration happening. No, cloud is a necessary evil. It will stay because when our definition of cloud our definition of cloud only includes AWS, Azure, big clouds. But we are using cloud in today's everything. Like as I already mentioned, Canva is a cloud. Office 365 is a cloud. Even we don't realize the things which we are using that is also hosted in a cloud. So career in cloud security sits between cloud architect and a security professional. So why career in cloud security is important? It's a booming industry. Salaries are lucrative, but we should not only look out for salaries, job satisfactions, and your career growth is equally important. And what you want from a life is important. Don't come to this just because there are good salaries. If you are interested, because there are some of my friends who are into network security who have a great thirst for technical things. So for them, yes, cloud, this is a good option. And it has diverse roles. As I already mentioned, and I will take you through, it's not only one type of roles available, there are multiple roles available. And it's quite a dynamic field. I started studying about cloud in 2017, and within 8 years, a lot of things have changed in a cloud itself. Every year, services are getting changed, new technologies are coming in. So that makes it a very dynamic field. Who all should go for cloud security? As I already mentioned, there are roles available for everyone. But whichever field you come from, in a cloud, you cannot survive without technical knowledge because cloud is pretty technical in nature. Like you can be a sales professional, but if you're selling AWS, Azure cloud, or any cloud services, you need to be aware of it. So you can be from different fields. I believe in one thing, mates, that nothing is impossible in this world. You can be a PMP professional, you can be an audit professional, you can be a trainer, can be from any field. There is no restriction on not on coming into this field, but you should be ready for technical. You should have that zeal to learn. So yes, if you are a network security professional, DevOps professional, senior management, yes, senior management they should need because they have investment these days. Cloud is being seen as a strategic option for saving the cost. So for that, they need to understand that. So there are different types of roles available in a cloud. As I already mentioned, technical roles and non-technical. Non-technical, it will not be purely non-technical, it will be semi-technical roles. So you have technical roles like cloud architect. He is the one who is responsible for designing and managing an organization cloud infrastructure and strategy. They create scalable, secure, and cost-effective cloud solutions using platforms like AWS, Azure, GCP. It's a pretty hardcore technical rules. It, cloud architect, this is a kind of a role which is not very commonly available because this is being required in those circumstances when you are moving from on-prem to cloud. So once in a lifetime kind of opportunity. But yes, minor migrations also happens. In that case, also the cloud architect works. Then engineer, it comes below it. It builds, deploys, and manage cloud-based infrastructure. They work on automation, monitoring. Then administrator, who manage the things. So now engineers has set up cloud architect has designed it. Engineer has set up the things. Now administrator job is to manage those things. Then you have a cloud security engineer. which design and implement security controls to protect cloud environment from threats. Their jobs include configuring firewalls, managing IAMs, managing BCP, helping security, embedding security into CI/CD pipelines. Then DevOps engineer. This is mainly a software developer role. You know what is DevOps? DevOps consists of whenever you are developing a software, you require three things: IT, software, and your quality team. And these three teams used to fight among each other. So, and who used to suffer? Customer. So in DevOps, what they have done, they have picked up people, they combine these three things together so that they work for the betterment of the customer. So this is mostly a software developer role because it's mainly about developing and all. Then cloud software engineers that deploy manages the cloud-based applications. So these are mainly technical roles. Then you have non-technical roles also available, like cloud project manager. It's a great role. Trust me. One of my friends, he was a SOC engineer. He did his PMP, and now he has worked in Akamai, and now he is working as a project manager in Azure Sentinel in Microsoft. So this is a great role. Then you have a cloud sales representative who promotes and sells cloud services and solution to potential client. Then a trainer, like me, I'm a trainer. Develops under even AWS Azure, they also need trainer to promote their services. And then the business analytics, the person who is responsible for improving the efficiency and reducing the cost. Like it evaluates the business needs and translates them into the cloud-based solutions. Then you can also have a cloud auditor, which assess the cloud environment for compliance, security, and operation efficiency. But again, these are non-technical is quite a misnomer. I would say it's more of a semi-technical roles because in a cloud, purely non-technical roles are not possible because cloud is in itself is pretty very technical in nature. So when I talk about career progression in a cloud, you can have entry levels, which where you can go for. Yes, Rama, nothing is impossible. I always says that you can learn at any age. I'm also 45 years old person. So if you look at the KFC guy, he started his career at 65. So age is just a number. If you have a zeal to learn the things, then definitely no one can stop you in this competitive world where talent is most important. So entry level cloud support engineers, you can be a security analyst, mid-level engineer, security engineer, DevOps engineer, and then you can be an architect, DevOps lead, practice manager. Trust me, it's a great field. You can get good money. I have seen people, my friends who are into cloud, earning money handsomely, but again, this is a field where you require continuous upgrades. So, and in today's world, it's not only about this field, in any field, with AI coming in within 2 years, the agentic AI comes in. Now we are working on uh, quantum computing is coming in. So, in today's age, where things are changing so swiftly and quickly that you can't ignore, if you're not upgrading yourself at a regular interval, that would be difficult. So this is about career progression. So now I'm coming to the another part, which is certifications. So there are different types of certificates. There are two categories of certifications made. One is your managerial vendor neutral certification, which is related to cloud, focus on governance, risk management, and strategic planning. So they are not tied to any specific cloud provider. This help professional align cloud initiative with business objectives and compliance. And then you have a technical certifications like AWS and Azure, which is specific and tied to your environment or to particular vendor. So these are some of the managerial and vendor neutral certification. I would say out of the two, I always suggest CISSP and CCSP is a deadly combination. But even if you don't want to, but there are people who only wants to make their career into cloud, then they can directly go for CCSP also. but CSSP is a baseline certification which sets up a good base for security. And then on top of that, if you go for CCSP, these are the two certifications you can go for it. It's too good. Means it can make your career. One of my friends, he's in Microsoft. He has these two certifications, and IC2 certifications. They are brand in itself because if you show your credentials in IC2, no one will doubt your credentials because they are managing and maintaining the integrity and dignity of certification. Then you have CCSK, CCAK, which is very specific to auditing. This is by ISACA. And then you have a CompTIA Cloud Plus. This is also a good certification, a beginner certification. So CCSK and CompTIA Cloud Plus, they are mainly for beginners, I would say. And CCSP, CCSP, 5+ years of experience. And AK is specifically meant for auditing field. Then technical certifications, that is your you can have there are multiple cloud vendors available. I suggest pick up at least two out of means one should for irrespective of domain, one should go for admin or associate certificate of at least two cloud providers. My suggestion is AWS and Azure. uh, they are the leader, but Google Cloud and Oracle are giving tough competitions. If you want to start, then there is a certificate, entry level certifications available in AWS, that is AWS Cloud Practitioner, and Azure Fundamentals. And there are admin level certifications also, which you can choose it on the basis of your requirement. So, domain specific certification, you can have AWS Security, AWS Networks, Azure Security, but these are very uh, specific certifications. One should not go for these certifications unless and until you are not working in these fields. Then you have a domain specific certification like Azure DevOps, AWS DevOps, Azure AI, AWS Big AI. So these are just some certification which you can choose on the basis of your expertise and on the basis of your interest and intent. So this is about your certifications. Now some final key pointers. Master the cloud fundamentals. I have already mentioned that understand the cloud models, IaaS, PaaS, SaaS, deployment types, and the core services of AWS, Azure, and GCP. I suggest, look, there's no need to go for certifications in the beginning. There, there are videos available. They are hands-on available because labs are available these days. You can easily log into those labs, but be careful about the financial part. Don't try to use the services which are paid. Earn the certifications. We have already seen what are the different certifications. Develop hands-on skills. Hands-on skill, gaining hands-on skill in cloud is pretty very easy because you have a console, you can easily subscribe and access it. But be careful about the finance part because they take your credit card details, and if you use any services which is paid, then you may end up paying a lot of money. One of my friends, he just provisioned the VM machine and he forgot to deprovision that VM machine. And what happened? And he has opened that VM machine on a public internet. Someone has used it and he had to pay 10,000 rupees for it. Understand about compliance and auditing, gain DevOps awareness, familiarize yourself with integrating security into CI/CD pipelines, stay updated from your CSA, CSA's Cloud Security Alliance, and ISTN cloud vendors. Build your own portfolios by document project case studies. Network and learn like you are attending my webinar, attend webinars, cloud security communities, and think like an attacker. Understand common threats like misconfigurations, data breaches, and all, and learn security concepts, IAM, logging, compliance. Look, theoretical knowledge is important, but at the same time, in a cloud, like it's very easy for you. It's easily available. Go and subscribe yourself to the AWS or Azure cloud, and you can easily see the consoles and do some hands-on without paying a lot of money. So hands-on knowledge, combination of both can make you a good cloud security professional. So thank you very much for this. Okay, so that is all about. So we have covered NIST 800-145, where we have covered essential characteristics, services model, deployment model. We have covered why cloud security is important. We have seen the certifications required, what are the different types of roles available in a cloud, and then some final key pointers. So this will help you in the first part that I've covered with you. If you are preparing for CISSP, CCSP and all, that will help you in that preparation of that part. The remaining part I have covered it from the career perspective. So thank you very much. Any questions? Rama, I think I have answered your question. So any further questions you can ask me, I can answer it. Any questions, anyone? You can write it on chat. I can. Okay. No questions. Then thank you very much for joining this session. We'll meet next week with when I will come up with some another session. Thank you.